Now, when we were talking about solving by substitution on Monday, I think it was Brooks that had a fabulous idea. So this is what I'm gonna do. Hold on. Okay, write that down.
You complaining, Brooks?
No.
She can give you no pencil at all. Grateful.
That's just like, hey, these go together. Kind of like music. Have you ever seen music? Like it kind of just braces them together like this is one. All right. What? Okay. Henry, what do you think? How'd you get that, Kyron?
7 minus 3 equals 4, but then 7 plus 3.
Did you get that any other way besides guess and check?
No.
Brooks?
I forgot. But I think if you like go down, you can like add all the equations together. So like 2x equals, so there's no y, so 2x equals 14.
Okay, did you hear that? Brooks said if you add these two together, the y's go away. Do you see that? So if, since y and minus y are opposites, if we were to add the two equations together, what's x plus x? And what's y plus minus y? Nothing. And what's 10 plus 4? Hey, Kyron, what's x?
Yeah, I like
Okay, now, how do we get y? Okay, doesn't matter which one. So x plus y equals 10, which means y is, okay, so we know our answer is 7, 3. Now, how do we know for sure that this is right? We can check it. Is 7 plus 3 equal to 10? Is 7 minus 3 equal to 4?
Yes.
You seem hesitant about that.
No.
Okay. Now, why was this so easy, as you said? But what made it nice?
It's a lot easier to solve.
What made it nice?
The y's.
Oh, the y's were opposite, right? Plus 1y, minus 1y, they were opposite, okay? So if we are going to solve by, this is called elimination because we are eliminating one of the variables. If we are solving by elimination, we want opposite coefficients for one of the pairs, whether it be x's or y's, we want opposite coefficients. That way, when we add the two equations together, they will cancel. Okay. Now, this one was really nice because it already was opposite. If they're not opposite, we would have to do some work to get them that way. So it is possible that we may have to multiply one or both equations by a number in order for us to be able to use elimination. Yeah.
Multiplication.
What?
Does it have to be multiplication?
Yes, it has to be multiplication. Okay. So once we have coefficients that are opposite, we can add them together. Okay, we're gonna add, we're not gonna subtract. We're gonna solve, and then we're gonna substitute back into one of the original ones to get our other variable. Okay, now, some of you are thinking, oh yeah, I like elimination way better than substitution. Okay, there are going to be times where substitution is better. There's going to be times where elimination is better. Okay, and as we go through today, we'll kind of talk about when that's going to be the case. All right, so go ahead and turn to the extra practice page. Let's look at number 1. Okay, what do you notice? The x's are opposite. So if we wanted to use elimination, we could add these two together. And Kari said the x's will cancel out. Since the x's are opposite, when we add these two equations together, we get 5y equals 25. Kyron. Now, you actually have to show me some work, Kyron. Okay?
Sorry.
You don't apologize, just do it. Okay? I know some of you can kind of see numbers in your head sometimes. That's really cool, but I need to see where they're coming from. I don't read minds, unfortunately. I'm glad I don't read minds.
What?
Okay, now which one would you prefer to put this back into? First one? Hey, does it matter?
No.
Sure does not. Okay, I'm gonna go the first one. X plus 3y equals 17. X is 2.
Right here.
Is 2 plus 3 times 5 equal to 17? Is negative 2 plus 2 times 5 equal to 8? Cool. All right. How about you try number 2? Number 2. I gave you a pencil. Huh? Yeah. I'm so sorry. Maybe this could be a lesson for you.
I did, I really yeah.
All right, so when Allison added these two together, she got 7x equals 21. Do you agree? Which means x is 3. Gabe, did you plug back into the first or the second one? So you said 2 times 3 minus y equals 5. What does that mean y is? So our answer is 3, 1. Are you bored yet? Yeah? Okay, so let's go to the next page. Let's go and look at number 10. Okay. Now, do we right now have a pair of variables that have opposite coefficients? We do not, which means we need to force it to happen. So we get to be in control. We get to choose, do we want to make the x's or the y's opposite? In this case, I don't think it's gonna matter.
I think it's the Y.
What do you want to do?
The Y's.
The y's?
Yep. the Y.
Let's vote. Who wants to make the x's opposite? Who wants to make the y's opposite? Okay, that wasn't really effective.
Exodus. Why?
Exodus?
No, Y.
Yeah.
Y. Y, bird. Y.
X, bro.
Who votes for X? Who votes for Y? Y's win. All right. If we want to make the Y's opposite, what would we need to multiply the second one by?
Maybe one Y.
So this is 2Y. What is opposite of 2? Okay. What is the current coefficient of Y in the second one? So if I wanted it to be -2, what would I need to multiply by?
-2.
Okay. So our first equation is 1 plus 2y equals 20. And our second equation is now -4x minus 2y equals -38.
I get it.
What?
Wait, what?
What's the problem?
X plus 2y equals 20.
So this -2 has to go to everything.
Oh, okay.
But then they're both opposite.
What?
Then they're both opposite.
You tell him, Kyron.
What do you mean both?
One's positive, one's negative, and then one's positive, one's negative.
Only one is actually opposite of the other. Because 2 and -2 are opposites, but 1 and -4 are not opposites of each other. Okay, now let's go ahead and add these two together. Do the y's cancel? And we have -3x equals -18. So what's x? Okay. Now we had like one extra step in there, but was it terrible? No, it wasn't terrible. Are you writing this down with us, Pat?
Yeah.
All right. Why are you depressed? Because I tricked you in your seating chart?
There's one more step. What's the right about this?
There is one more step. What do we need to do, Harry?
Find the Y.
Okay, which one do you want to use, Harry? The top one? Interesting choice. X plus 2y equals 20. Yeah. You're saying y equals 7.
I'm agreeing.
So 6, 7 would be our coordinate of intersection. Let's test it out. Is 6 plus 2 times 7 equal to 20? Is 2 times 6 plus 7 equal to 19?
Yeah.
Yep. Okay. Yeah. Let's look at number 11. Do we have a set of variables with opposite coefficients? No.
Brooks, is this one of the classes?
Okay. What we need to do is we need to multiply one or both of these equations to force x's or y's to be opposite. Does anybody have an opinion?
I would multiply by a negative and then a positive 3.
I don't think that would help.
For the y's.
If we want to make the y's opposite, y's for life. Okay, what could we multiply the first one by?
Positive 1/2. No.
Negative 1/2.
What?
Negative times negative.
So what if we multiplied by 3?
Why?
Because then the coefficient would be -6.
Oh.
Then we would have to multiply this one by -2. Let's, if we multiply this equation by 3, then we would have 9x minus 6y equals -6. Okay. If we multiply the second equation by 2, we would have -2, excuse me, we'd have -8x plus 6y equals +8. Why did I choose 3 and -2? Because now my y's are opposites. Okay. So what we did is we focused on, okay, I want the y's to go away. So I am going to pick a number to multiply to each of them to where my y's will end up being opposites. Okay. So I chose 3 and -2. That way my y's are now -6 and 6.
But isn't the 3 on the bottom one a negative?
Which is why negative times a negative gave me a positive.
I know, but for the top one, it's like multiplying by 3.
Yeah, +3.
Yeah, where'd you get that from?
I chose it.
Didn't tell him.
Pulled it out of my butt.
Like, what if you do like a 4 there?
What?
That would say.
If I chose 4, that would not help me any. Because then I wouldn't have anything to multiply. Like if I multiply this by 4, then I have -8y. Well, if I want the y's to be opposite, I don't have anything to multiply to 3 to get to 8.
Oh.
Do you see what I'm saying?
Yeah.
Okay, so I didn't like just pull it out of thin air, but I said, ooh, if I multiply this by 3, then I could multiply this by -2 and we would be opposites. Yes.
So we have to have fractions.
Not probably for coefficients, but for answers, yeah. All right, here we go. Let's do this. If we add these together, our y's cancel out. What do we have here?
1x.
We have x equals 2. Oh, that was so much work.
Too much work for me.
All right, where do you want to go back to? First or second?
Something, 1.5.
So 3x minus 2y equals -6. Thank you for paying attention.
You're welcome.
Yeah. Okay, so we have -2y equals -8, so y equals 4. So 2, 4. Allison, what can I do for you? Your face does not say that. Brooks, not quite yet. What I'd like you to do, I want you and your elbow partner to do number 12.
No. What? No, we're not. Oh, no, we don't have to. Oh, I see. I got 34
Fractions are our friends.
Fractions are not our friends. I'm hungry. I just hungry. Wait, so this is the. Isn't it shaking? I didn't Oh, I didn't do it. Wait, what? What are you doing? Oh, it's learning So you gotta do like negative 102 divided by. Yeah, but then we got down to say that we need to know that's what How did I get 1/2? Six divided by 30. Not my year. No, 17 is divided by
Okay, make 5. Make 5. Make 5. Some of you are getting really grouchy. And then stopping instead of pushing through. We need one set of variables to be opposite. Is that the case right now?
No.
No. Would it be easier to choose X's or Y's?
X's.
X's, because we have 9 and 3. All we would have to do is multiply this second one by a -3, and then our X's would be opposite. So this is what I'm gonna do, and this is what I do not see happening. I am going to rewrite 9x plus 4y equals 11. I'm gonna rewrite it so that underneath I can write -9x plus 30y equals 6. Some of you are not stacking them, and then you're misadding. Stop being lazy. What'd you do?
I don't know, but I got it.
So you, okay. So Connor multiplied the first one by -10 and the second one by -4. So that the X's or the Y's would become opposite. Guess what? He did maybe a little bit more work than you, but he got the same answer, okay? Because what happens here is our X's go away and we have 34y equals 17. Don't freak out. When we divide 17 by 34, we get 1/2.
I told you. I got
Then we're gonna take 1/2 up here, 9x plus 4 times 1/2 equals 11. So 9x equals 9x equals 1. Okay, now I have a question. Some of you are whining about this. Would you rather solve for x or y and use substitution?
No,
Nope.
absolutely.
Because in this problem, if we were to solve for x or y in either equation, we're working with fractions the whole time.
Yeah.
Whereas we only had a fraction in our answer at the very end. Okay, now, what about, we're not going to do it, but let's talk about, I guess right here. What if I gave you this problem right here? Don't go to it because we're not going to do it. Would elimination be our best answer here? No, it is already solved for y. We can use substitution right now. Okay. In number 8. Right? In number 8. Substitution. We're not ready for substitution, but we can get there really quick, can't we?
Yeah.
We could divide by 2 and bam, we're ready for substitution. Okay.
I'm starting to understand what you're using. So much more stuff.
Yeah.
I'm so right now.
Has a clear way which
Remember what? We just talked about it. Okay. The sum of 2 numbers is 22. The difference is 6.
Oh, yeah.
Raise your answer. Raise your hand if you know how to set up the first equation. Henry. The sum of 2 numbers is 22. The difference is 6. Allison.
Oh, is that? X minus x equals 22.
I don't know.
The difference. X minus y equals 6. The difference, subtract them, is 6. X minus y equals 6. Sure. But hey, look at this right now. It's set up for what? Elimination. I can already see that 2x equals 28.
Elimination.
So what does x equal?
14.
Y is what?
8. Why do you subtract it? Yeah.
Difference?
Oh, it's 2x. Oh.